Okay, this is a demonstration of titration for laboratory number 4, acids and bases, and we're going to titrate vinegar, do a titration to determine the amount of acid, acetic acid, in grocery store variety vinegar. So our unknown material is grocery store variety vinegar. Our known material is sodium hydroxide. The package says that it is 1.0 molarity. I'm going to determine that exactly, and I will tell you before class what the exact molarity is. Our experimental setup is a burette. This is a burette, this long piece of glassware here. I have a funnel inserted at the top, and it's in a ring stand here, so you can see it there. Right now I have a 250 milliliter waste beaker underneath there. I also have a clean 150 milliliter beaker. This will be where I'm doing the reaction. And I have some vinegar in a small beaker. I have about 10 milliliters here. Okay. Now, let's see. I also have phenolphthalein. I have a graduated cylinder of water. And I have a pipette and a pipetter and a disposable pipetter. Okay? Now, the first thing I'm going to want you to do is get some sodium hydroxide in like a 100 milliliter beaker. Just get about 30 milliliters, and myself and the teaching assistant will assist you in that. But get some of the sodium hydroxide. Be careful with it. Have gloves and goggles on as you're handling the sodium hydroxide. The first thing we want to do is to run a little bit of sodium hydroxide through the burette just to make sure that we've got it tuned in to our experiment and make sure that we have flushed away and pre-reacted any contaminants that might have been in the burette from a previous experiment. Now, I have already done that here, so I'm not going to do it now. But what I want you to do is when you first set your burette up, okay, like this, with the waste beaker underneath and this valve closed, this valve, when the little stems are horizontal, that means it's closed. When they're vertical, it is open. I want you to pour some sodium hydroxide in very carefully. Pour enough into the funnel. I'm just pantomiming it here because I've already done it. Fill it up to about like 4 inches up the height of the burette, okay? And then open this valve and drain all of that into your waste beaker. And like I said, the purpose of running some of this sodium hydroxide through there initially is just to tune in the burette, make sure you have pre-reacted any contaminants that might be in the burette. Like I said, I'm not doing it in this video because I've already done so, but I want each team to do that before you start your experiments. Okay, after you've done that and you've drained that pre-quantity of sodium hydroxide into a waste beaker, then I want you to close this valve. Then I want you to fill the burette up with your remaining sodium hydroxide, which should be about 20 or 30 milliliters, minus whatever you dumped in there to begin with. Okay, then I want you to take a look at this, check that there aren't any air bubbles in there or like a drop of sodium hydroxide there that might interfere with your ability to accurately measure how much sodium hydroxide has gone into your reaction beaker. If you need to, open that valve a little bit, drip a little bit more out of there, and close the valve, wait till everything is very stable and you're very happy with the setup. Then remove your waste beaker. Okay. Then we want to very accurately measure what is the level of our burette. Now, we didn't get a chance to practice this in the first lab, so this will be your first chance to do so. Remember that the burette, the scale goes opposite of what you think. The small numbers are at the top, big numbers are at the bottom. You can see the liquid level in this burette somewhere between 28 milliliters, 27 milliliters, and 28 milliliters. Might help if you put a piece of paper back there. We want to very accurately see where is the level of that liquid. Okay, so I'm saying it's about Now 27.3, remember I'm reading down the numbers down from the top. 27.3 and a little more than that, so 27.32. Okay, that's my initial barrette reading. So I'm going to put that in my data collection here as the initial barrette reading. Initial reading of the barrette is, what did I say, 20... Now I got to do it again because I don't remember. So I said 27.32. So 27, so I'm writing down 27.32, right? Okay. Now we're ready to start our titration. Now, like I said, this is going to be our reaction beaker. It is a 150 milliliter beaker. The size of the beaker is not really important. Just this is kind of a good size. Now, I want to first get 5 milliliters of vinegar. Now, I poured a small quantity into a 50 milliliter beaker. You should start with about 15 milliliters or so. Okay, then I'm going to pipette exactly 5 milliliters out of there. See if I can do this one-handedly. Now the pipette, hold it like this. Use your thumb to run that thumb wheel to draw liquid up. Now again, the pipette goes the same way with small numbers at the top, big numbers at the bottom. Okay, and you have to do this by subtraction. So we need to run the liquid up to a level higher than, quantity greater than 5 is in there, okay? So I've got it up to the 4. Okay, let's see if you can see that. Liquid level is at the 4. And then I'm going to, excuse me while I switch hands here, I'm going to run the liquid level down to the 9. I'm using my thumb to run that plunger down, and I want to stop right at the 9, as accurate as I can. And there it is. Okay, so I'll return the rest of that material to my little supply. Now I have 5.0 milliliters of vinegar in my reaction beaker. So let's put that down. So my initial volume of vinegar is 5.0 milliliters. Okay? Now, we can add a little bit of water to that. Well, we can add water so we have a higher, just a greater volume to work with. Now, the amount of vinegar in there is set at 5, so it doesn't make any difference how much more liquid I add. I know that my initial starting material of the vinegar was 5 milliliters. So I'm going to add 25 milliliters of water just to have a good quantity of liquid in there to work with. So I'm adding 25 milliliters of water. Now I'm going to add the indicator, which is phenolphthalein. And I only need about 2 to 3 drops of phenolphthalein here. So just, here we go. 1, 2, that should be sufficient, okay? And I used a disposable pipette to put the phenolphthalein in so that we can reuse it and for multiple experiments, okay? So let me close that up. And I'm going to put this under here. And so this is our reaction material. It's underneath the barrette. Now remember, the barrette contains our known material. All we know its molarity. We don't know the volume of the sodium hydroxide is going to need to neutralize the acid in the vinegar, but that's what we're about to determine. We know the volume of the vinegar that we added. Now, if you remember correctly, phenolphthalein is clear in acidic solutions. It will turn pink in basic solutions. So right now, the total solution I have here is acidic because the phenolphthalein is clear. So I'm going to start adding small quantities of the sodium hydroxide. I will just open and close this valve momentarily and watch what happens. So I'm going to add just a little bit here. Okay, and you can see that when the sodium hydroxide poured in there, initially we got a little flash of pink color. That's because locally the solution had turned basic, the phenolphthalein turned pink, but then when that quantity of sodium hydroxide got mixed in, it went back to clear. So we're not anywhere near the equivalence point yet. So I'm just swirling a little bit to get it mixed in nicely, and I'll do that again. Add a little bit of my sodium hydroxide. Again, you see it turned pink momentarily, but as I swirl it, it gets mixed in, and goes back to a clear solution, indicating that I'm still short of the equivalence point. So let's add a little bit more. Again, I get that flash of pink, which goes away as I mix it in. It persists a little longer, meaning I'm getting closer and closer to the equivalence point. When you see that pink color persist for a little while, then you know you're getting closer. So I'm going to be very careful on the quantities I add. This time just added a few drops. Get that mixed in. You see it's taking longer for the sodium hydroxide to get mixed in. And just keep doing this procedure, being very careful. Again, I get a little pink color. It's very persistent, or a little more persistent. Oops, that was more than I wanted. Hopefully I'm okay. Let's see if that gets mixed in. We're looking for a color change that persists. So I give it a little bit of mixing, and then if it goes back to clear, that means we're still short of the equivalence point. Equivalence point meaning that we have neutralized all of the acid in our sample with the sodium hydroxide. So let's see if I can just carefully add a little bit here. Mix that in, it goes away. Now you can see that the pink color is being relatively more persistent as I mix it in, but it still goes back to clear, so we're still short of the equivalence point. Now the pink color is being very persistent, but it still goes away, so we're still short of the equivalence point. Okay, now you can see that it has turned pink, and it is not going away as I swirl it to mix it in. So I would say that we are at, or maybe a little past, the equivalence point at this point in time. So we have exactly neutralized all of the acid in the sample with the sodium hydroxide that we added. So the only thing left to do is determine how much sodium hydroxide did we add, And the way we do that is we read the barrette again. So let's go back here and zoom in on that. Let's put a piece of paper back there to make it easy to read. So it is somewhere between, the level is between 31 and 32. So remember, we're counting down from the top. So what do we got there? We've got, it's less than 31.3. So say 31.28. 31.28. So I go back to my sheet. Final 31.28. Okay. Then all I have to do, I've got this information, and then I just do the subtraction and find out what is the volume of the sodium hydroxide that I added. And that's all there is to the experimental technique. I'll make another video to describe how we analyze the results, but the only thing left to do is to clean up now. If you're doing another run, then I want you to, you can dump this into your waste beaker, then rinse this beaker out, give it a rinse with tap water, then deionize water. You don't have to dry it, because remember, add extra water does not hurt you. And then you can do another run, same process that we did before. If you're done, then dump all of your chemicals, clean out the pipetter, and clean your beakers as you do a good job of, and you're done. So I'm going to stop this video at this point in time.